Hello everyone, my name is Alexis JEANTET. I'm a PhD student in Subsurface Drainage Modeling under the supervision of Julien Tournevis from INRAE and Philippe Martin from AgroParisTech. The topic of my thesis deals with the sustainability of subsurface drainage under climate change. I'm in the second year of my PhD at INRAE in the Jouy-en-Josas-Antony Center. My PhD was co-funded by Sealand at INRAE and is part of the Sealand Challenge 2 dealing with agriculture and forestry under climate change. First, I will show you a quick reminder of the subsurface drainage concept. It's an hydraulic system consisting of introducing a perforated pipe into the ground in soil showing waterlogging issues, such as hydromorphic soils. This system permits to reduce flood risk and increase agricultural yield due to better soil aeration. The dimensions are currently next to 1 meter in depth and 12 meters for the spacings between two drains. This system is applied on 9% of French arable soils, including 12% for cereal type field crop. So the question is, what about the sustainability of such a system under climate change? The main purpose of my topic is to define the beckoning of the French subsurface drainage from an hydrological and environmental perspective under climate change by 2100. The first part is to develop the subsurface drainage modeling approach. So on the one hand, the SIDRA-RU model is developed to simulate drainage discharge at a daily time step. And on the other hand, the latter model is assessed following its capacity to represent drainage discharge, drain-water balance, and its temporal robustness over a database compiling 22 French sites spread over the French pedoclimatic condition. The second part I'm currently working on consists of the development of hydrological indicator of subsurface drainage, which will be analyzed under climate change. The objective is to represent the main characteristic of subsurface drainage, such as drainage temporality, flood event, or drain water balance. Next, the uncertainty cascade generated using climate change projection into the SIDRA-RU model will be assessed. To do so, we will use two other drainage models, the macro model and the drain mode model, to relatively compare their performances to the SIDRA-RU performance fed by climate change projection. Eventually, the third part will consist of generate the hydrological indicator under climate change on the 22 French sites and the climate change impact on water quality and agricultural practice will also be studied, but for now the use approach is not clearly defined and will depend on the remaining time after the completion of the previous purpose. Now I will show you some results of the robustness study made on the 22 sites of SIDRA-RU. These sites are spread over the main drain area and are classified following the three main soil textures, silty clay soil, and clay soil, and accumulate almost 200 hydrological years of data. This is a significant database which well represents the French drainage diversity. The SIDRA-RU model is fed by daily rainfall and potential evapotranspiration data, here provided by the Safran database. The calibration process is required for 4 parameters on each plot. And in this study, we choose to use the KGE criterion as objective function for the calibration. This criterion is ranged from minus infinite to 1, the latter giving the best performances. The model is assessed following the KGE value and by graphical comparison between observed and simulated discharge. A split sample test is required to assess the temporal robustness of the model. This test consists of splitting into two equal parts the observed data to calibrate the model on each part. So to obtain a parameter set and the corresponding KGE value in calibration on each part, and to use each parameter set on the other part to obtain a KGE prime value in evaluation. If the KGE prime value in evaluation are close to 1 in calibration, so the model is considered as temporally robust. The score of the KGE value in calibration shows that for almost all the 22 sites of the database, the SIDRA-RU model show at least acceptable performances, with 9 sites showing very good performances. The SIDRA-RU model is especially performant to simulate drainage discharge on silty soils, representing above 80% of French drains plot. Here we have a graphical comparison between observed and simulated discharge at the Lajalière plot. The figure shows that both red and blue curve follow the same trend and are almost merged all the time. So the graphical comparison shows that the SIDRA-RU model well represents the discharge, as well as the cumulative drainage discharge, and so the drain water balance. The last analysis I will show you deals with the comparison between the KGE value in evaluation to the KGE value in calibration. The figure shows that the KGE value in evaluation are close to 1 from the calibration and follow the line 1 to 1, and shows that on almost all the cases the model is quite robust, especially on silty soils. Results on clay soils are weaker, but considering that in the literature the simulating drainage discharge on clay soils is a common issue, we can assess that the SIDRA-RU model is quite performant. All these results show that on all the contexts, the SIDRA-RU model can be useful to simulate drainage discharge at the French national scales and be useful to the part 2 and 3 of the thesis. Thank you for your attention.